Number 58, based on the periodic trends and the data in the table above, which of the following are most probable values of the atomic radius and the first ionization energy of potassium, respectively? So if you guys refer back to the periodic table, right, we have calcium, which is basically number 20 on the periodic table, and potassium, which is number 19 on the periodic table. So let's talk about the atomic radius. Now, what determines the atomic radius? Basically, the number of protons, right? Because the more protons you have, the more pulling it does, because it's got more greater effective nuclear charge. So more protons pull those electron clouds more towards the nucleus, aka the atomic radius shrinks, right? So since calcium is number 20 versus number 19 potassium, it's got one more proton. So calcium's got one more proton, greater effective nuclear charge. It pulls in better, so atomic radius better be bigger, well, smaller for the calcium and therefore bigger for the potassium. Once again, potassium is a little bit bigger because it's got one fewer proton. It doesn't pull the electrons towards the nucleus as much as the calcium does, so not as much of the shrinkage happens, which is why potassium has to be at a bigger atomic radius than calcium, so get rid of C and D. And in terms of the first ionization energy, well, this once again has to do with the effective nuclear charge, right? Calcium has that one extra proton compared to potassium. It's got stronger pull that it is doing to the electrons. So it drags the electrons better and better towards itself, towards the nucleus. So if you're trying to pluck that off, well, it's going to be a lot harder for whichever one that has a greater strength of pull, which once again is calcium. So the ionization energy must be greater for the calcium and less for the potassium. So something less than 590, probably answer choice B is correct because A's got 633, which is bigger than 590, but that makes no sense. So get rid of A, it's got to be B.